you can see that in this circuit, R1 and R2 have to be considered two separate resistors because there's a junction that separates them. So first you have to consider combining all of the resistors into one to determine the current across the total voltage and the total resistance. So to do that, first you have to combine R2 and RL into one because they're parallel to each other, so you have to take the reciprocals of each separate resistor and add them together, and that will give you the reciprocal of the total voltage, or the total resistance. You can simplify that to just this. And that's that diagram right there. So then R2L and R1 are in series with each other, so you can just add the resistances together to get the total resistance, which would be right here. And you know that Ohm's law states that the total voltage is the current times the resistance. So you can find the current using the total voltage, which is given as Vs, over R, which is the total resistance that we already found. And that simplifies to this. And you know that in a series, the current through both resistors will be the same in a series because they're going through the same loop. This means that you can find the voltage through R1 using the current that you just found right here. And then I'll give you this equation here. So you know that in a series, voltages are additive. So the total voltage will equal V1 plus V2L. And to find just V2L, you have to subtract the voltage, the total voltage, and the voltage of just resistor 1. And we know that in a parallel series, or in a parallel circuit, the voltages will be the same. So the voltage of the total parallel circuit is going to be equal to VL. So then you can use Ohm's law again to find the current going through resistor L using VL over RL, which gives you that equation there. And then that simplified leads to this equation here. And I selected random values for RL, L, A, and VS. I selected 100, 5, 40, and 20 respectively. And I put it into Wolfram Alpha, and I plotted it, and I came up with this graph here, and then this one also. And these graphs make sense because as x increases, the value of R2 increases. You can see in the diagram that if the length of the variable resistor increases, more of the resistor will be in R2 rather than R1. So that increased value of R2 will pull more of the resistor into a parallel series with, or into a parallel circuit with RL. And that means that there will be less resistance overall, which means more current will be able to be pushed through each resistor with the given voltage. And that can be seen in the graph because as x increases, the current also increases.